Why are so many people turning back to animal-based nutrition, even in the era of plant-based diets? In this video, we dive deep into the science, history, and anthropology behind this shift. Discover the fascinating evidence that connects animal-based foods to optimal health, from the cellular processes in our bodies to the dietary habits of our ancient ancestors. Join us as we explore why animal foods may be the key to unlocking your full health potential, far beyond what plants alone can offer. Cellular health and the role of animal fats. At the most fundamental level, our bodies are made up of trillions of cells, each surrounded by a membrane that is vital for maintaining cellular integrity, communication, and proper function. The health of these membranes is directly influenced by the nutrients we consume, especially fats. Cell membranes are primarily composed of a lipid bilayer, which includes phospholipids, cholesterol, and proteins. Among these, cholesterol plays a central role in maintaining membrane structure and function. Predominantly found in animal products, cholesterol helps regulate membrane fluidity, permeability, and signal transduction, ensuring that cells operate efficiently. Without sufficient cholesterol, membranes can become too rigid or too fluid, impairing cellular communication and nutrient exchange. Animal-based foods are rich in saturated fats, which contribute to the stability and resilience of cell membranes. These fats help maintain the membrane's integrity, especially under conditions of stress, such as temperature fluctuations or oxidative damage. On the other hand, plant-based diets are often high in polyunsaturated fatty acids, or PUFAs. While some PUFAs are essential in small amounts, excessive consumption can lead to overly fluid cell membranes. This imbalance can make cells more vulnerable to damage, impair signaling pathways, and potentially disrupt critical functions such as hormone binding and nutrient transport. Animal products provide highly bioavailable forms of essential nutrients, including vitamin B12, crucial for DNA synthesis and cellular energy production, heme iron, easily absorbed and vital for oxygen transport and cellular respiration, and zinc, which plays a critical role in enzyme activity, immune function, and cell division. In contrast, plant-based sources of these nutrients are often in forms that the body absorbs less efficiently or must convert, which can strain metabolic pathways. For instance, non-heme iron from plants requires higher intake levels to match the absorption of heme iron from animal products. Animal-based sources such as fatty fish provide long-chain omega-3 fatty acids, EPA and DHA, which are integral to brain health, anti-inflammatory processes, and cellular signaling. While plant sources like flax seeds and walnuts offer ALA, alpha-linolenic acid, the body's conversion to EPA and DHA is inefficient, making animal-based omega-3s a superior choice for meeting physiological needs. Understanding the composition and needs of our cell membranes reveals why animal fats are indispensable for optimal cellular health. From stabilizing membranes to providing bioavailable nutrients and essential fatty acids, these fats support not just cellular function, but overall bodily health. A diet that includes animal fats aligns more closely with our biological requirements, helping to sustain energy production, hormonal balance, and resilience against oxidative stress. The human brain is a marvel of evolution, with its structure and function heavily influenced by diet. A closer look at the relationship between nutrition and brain health reveals why animal-based foods have played and continue to play a vital role in cognitive development and mental performance. Anthropological and evolutionary biology strongly support the hypothesis that the growth and complexity of the human brain were facilitated by the inclusion of animal foods in the diet. Meat and other animal products provided a concentrated source of calories, proteins, and essential fats, which supported the energy demands of an expanding brain. Compared to plant-based foods, the dense caloric content of animal products allowed early humans to allocate less time to foraging and more to activities that spurred cultural and cognitive development. The development of tools for hunting and cooking animal foods also coincided with significant jumps in brain size, as these innovations improved nutrient extraction and caloric efficiency. The brain is composed of about 60% fat by dry weight, with long-chain omega-3 fatty acids playing a pivotal role in its structure and function. DHA, docosahexaenoic acid, is critical for brain cell membrane integrity, synaptic plasticity, and neuron communication. DHA deficiency has been linked to cognitive decline, mood disorders, and poor brain development. EPA, eicosapentaenoic acid, known for its anti-inflammatory effects, supports brain function by reducing neuroinflammation, which is implicated in conditions like depression and Alzheimer's disease. While some plant foods, such as flax seeds and walnuts, contain ALA, alpha-linolenic acid, the body's conversion of ALA to DHA and EPA is less than 10%. This inefficiency makes direct consumption of animal sources like fatty fish, eggs, and grass-fed meat crucial for meeting brain health needs. Choline is an essential nutrient required for brain health and development. Choline is a precursor to acetylcholine, a neurotransmitter involved in memory, learning, and muscle control. During pregnancy, adequate choline intake is critical for fetal brain development, impacting memory and cognitive abilities later in life. Rich sources, animal products like eggs, especially the yolk, liver, and poultry, are excellent sources of choline. In contrast, plant-based diets often fall short, increasing the risk of deficiencies that may impair cognitive function. Vitamin B12, exclusively found in animal products, is indispensable for brain function. B12 is essential for producing and maintaining the myelin sheath, which insulates nerve cells and ensures efficient signal transmission. Insufficient B12 can lead to cognitive impairment, memory loss, and even irreversible neurological damage. Plant-based eaters must rely on supplements or fortified foods to meet this critical need, as plant sources do not provide bioavailable B12. Iron, particularly in its bioavailable heme form found in animal products, is vital for cognitive performance. Iron supports the production of hemoglobin, ensuring the brain receives adequate oxygen for optimal function. Iron deficiency, common in diets lacking animal foods, is associated with fatigue, poor concentration, and impaired memory. The alignment between our brain's nutritional needs and the nutrients abundantly found in animal products underscores their irreplaceable role in cognitive health. From the evolutionary leap enabled by nutrient-dense animal foods to the direct provision of essential fatty acids, choline, B12, and heme iron, animal-based nutrition is uniquely tailored to support brain function and development. While plant-based diets can complement these needs, achieving optimal brain health without animal products often requires significant supplementation and careful planning. Organ meats, often referred to as nature's multivitamins, provide a unique spectrum of nutrients that distinguish them from other food sources. While earlier chapters discussed key nutrients like B12, heme iron, and essential fatty acids, this chapter focuses on additional aspects of organ meats that contribute to overall organ health and systemic function. Organ meats are not just nutrient-dense individually, their nutrient profiles work in synergy to support specific organs and bodily functions. The liver itself is rich in natural folate, choline, and antioxidants like glutathione, which support detoxification and metabolic regulation. These nutrients enhance the liver's ability to process toxins, synthesize proteins, and regulate cholesterol levels. Heart meat is one of the richest dietary sources of coenzyme Q10, a compound critical for energy production in cells, particularly in organs with high energy demands, like the heart itself. Coenzyme Q10 is also associated with reducing oxidative stress and supporting cardiovascular health. Selenium, particularly abundant in kidneys, is essential for thyroid hormone production and protection against oxidative stress in the thyroid gland. Unlike muscle meats or plant-based foods, organ meats offer unique bioactive compounds that directly benefit human health. Vital for enzymatic reactions, organ meats, particularly liver, are rich in copper, a mineral crucial for the formation of red blood cells, maintenance of connective tissue, and neurological health. Copper and zinc, often found together in organ meats, work synergistically to support immune function and antioxidant defenses. Vitamin K2, menaquinone, the bone and cardiovascular protector, found in organ meats and animal fats, K2 directs calcium to bones and teeth, preventing its deposition in arteries. Synergy with vitamins A and D. These three fat-soluble vitamins work together to promote skeletal health, regulate immune responses, and optimize cellular function. Taurine, an amino acid-like compound found in high concentrations in heart and liver, supports electrolyte balance, bile salt production, and cardiovascular health. It has been shown to lower blood pressure, reduce inflammation, and improve heart function. Glutathione, the master antioxidant, found in organ meats, particularly liver, glutathione plays a key role in neutralizing free radicals, supporting immune function, and aiding in detoxification processes. Consuming dietary sources of glutathione enhances the body's own production, particularly in stressed or nutrient-deficient states. Organ meats like kidney and connective tissues contain glycine and collagen, which are vital for skin elasticity, joint health, and gut lining integrity. While previously mentioned in Chapter 1, it's worth noting that retinol from liver also supports reproductive health and improves night vision, functions that go beyond its cellular benefits. Organ meats contain peptides that promote tissue repair and modulate inflammation, making them invaluable for recovery and immune resilience. Eating organ meats provides nutrients in forms and ratios that directly benefit corresponding human organs, following the like supports like principle observed in traditional medicine. For instance, liver for liver health. The nutrient density of liver helps replenish stores of B vitamins and supports liver regeneration. Heart for heart health. The coenzyme Q10 and taurine in heart meat directly support cardiovascular efficiency and resilience. Kidney for kidney health, rich in selenium and potassium, kidneys support electrolyte balance and antioxidant defenses. In a world where processed foods dominate and nutrient deficiencies are common, incorporating organ meats is one of the most effective ways to restore balance. While plant-based foods provide essential macronutrients, they often lack the concentration and diversity of micronutrients found in animal-based foods. Organ meats are a nutritional powerhouse that uniquely address the specific needs of human organs and overall health. By offering a rich combination of vitamins, minerals, amino acids, and bioactive compounds, they enhance detoxification, cardiovascular function, hormonal balance, and cellular resilience. Including organ meats in the diet bridges gaps left by modern eating habits, promoting a level of nutrient density that is difficult to achieve otherwise. The dietary patterns of our ancestors, shaped by millions of years of evolution, provide crucial insights into the natural human diet. From hunting practices to the physiological impact of food choices, historical and anthropological evidence underscores the central role of animal foods in shaping human development and survival. Prehistoric tools and hunting archaeological discoveries show that early humans developed specialized tools, such as hand axes and spears, primarily for hunting and processing meat. These advancements marked a significant shift in dietary patterns, enabling humans to extract more energy and nutrients from their environment. Early humans also utilized tools to crack open bones for marrow, a dense source of fat and calories which likely played a critical role in supporting brain development. Cave paintings found across Europe, Africa, and Asia prominently feature depictions of hunting and large game animals. These visual records highlight the reliance on and reverence for animal foods within early human societies. Hunting was more than a survival strategy, it was a cornerstone of social bonding and cultural practices. The cooperative nature of hunting encouraged teamwork, communication, and planning, key factors in the development of complex societies. Nitrogen isotope analysis from skeletal remains consistently points to a diet rich in animal protein, with isotope levels aligning more closely with carnivorous species than herbivores. These findings suggest that early humans thrived on diets where animal foods provided the majority of calories, particularly in environments where plant-based options were limited or seasonal. The control of fire and the advent of cooking allowed early humans to access more calories and nutrients from animal foods. Cooking breaks down collagen and connective tissues, making meat easier to digest and more energy efficient to consume. The high energy yield from cooked animal foods was likely a critical factor in supporting the evolution of larger, energy-intensive brains, setting humans apart from other primates. Approximately 10,000 years ago, the agricultural revolution introduced a grain-based diet, marking a dramatic shift from the hunter-gatherer lifestyle. While agriculture provided food security, it also led to a decline in dietary diversity and nutrient density. Studies of ancient remains show that early agricultural societies experienced a decline in health compared to their hunter-gatherer predecessors, with higher rates of tooth decay, shorter stature, and signs of nutritional deficiencies. Given that humans evolved over millions of years as hunters and gatherers, the relatively short span of agriculture may not have been sufficient for our physiology to fully adapt to a grain-centric diet. The consumption of nutrient-dense animal foods, including fat and protein, played a pivotal role in the expansion of the human brain. Key nutrients such as DHA, iron, and B12 are vital for cognitive development and function, and these were readily available from animal sources. The high-quality protein in animal foods supported muscle growth, strength, and endurance, enabling early humans to excel in physically demanding activities like hunting and foraging. Animal foods provided essential micronutrients like zinc and selenium, which are critical for immune function, helping early humans withstand infections and environmental challenges. The dietary patterns of our ancestors offer compelling evidence that animal foods were integral to human evolution. From the development of hunting tools to the nutrient benefits of cooked meat, our physiology and biology were shaped by a diet centered on animal foods. While the advent of agriculture introduced new food options, the core principles of our ancestral diet continue to resonate. Nutrient density, bioavailability, and the central role of animal foods in sustaining health and vitality. These findings challenge the suitability of plant-exclusive diets for optimal health and highlight the importance of aligning modern eating patterns with evolutionary dietary foundations. As individuals, we adopt diets ranging from plant-exclusive to meat-centric. The long-term effects of these choices are becoming increasingly evident through research. Understanding the strengths and limitations of various approaches can help inform more balanced and sustainable nutritional practices. Research consistently shows that vegan diets are associated with deficiencies in critical nutrients such as vitamin B12, essential for nerve health and red blood cell production. B12 is not naturally present in plant foods, leading to risks of anemia, fatigue, and irreversible neurological damage if left untreated. Non-heme iron from plants is poorly absorbed compared to heme iron in animal products, increasing the risk of iron deficiency anemia. Calcium and vitamin D. These nutrients are crucial for bone health, and insufficient intake can lead to a higher risk of osteoporosis and fractures. Omega-3 fatty acids, DHA and EPA, critical for brain function and heart health. These are largely absent in vegan diets as plant sources provide only ALA, which the body converts inefficiently into DHA and EPA. While supplements can mitigate some deficiencies, they may not fully replicate the nutrient synergy found in whole animal-based foods. The rise of ultra-processed vegan alternatives, such as plant-based burgers and snacks, has raised concerns due to their high content of added sugars, contributing to weight gain and metabolic disorders. Many products contain industrial seed oils like canola and soybean oil, which are high in omega-6 fatty acids and can promote inflammation. Excess sodium, linked to increased blood pressure and cardiovascular risks. Studies have linked high consumption of ultra-processed plant-based foods to a greater risk of obesity, type 2 diabetes, heart disease. While these products offer convenience and mimicry of animal foods, they often lack the nutrient density of whole, unprocessed options. A study by Harvard researchers examined over 2,000 individuals following a carnivore diet, revealing significant health benefits. Many participants reported significant reductions in body fat, likely due to the satiating effects of protein and the absence of processed carbohydrates. Anecdotal reports suggest cognitive benefits, potentially linked to the elimination of inflammatory foods and the brain-supporting properties of animal-derived omega-3s and B vitamins. Participants often reported improvements in gut health, with reduced bloating and gastrointestinal discomfort, possibly due to the absence of fermentable fibers and anti-nutrients like lectins. Diets that incorporate both plant and animal foods, such as the Mediterranean diet, consistently show strong evidence for promoting cardiovascular health, longevity, reduced risk of chronic diseases. Combining nutrient-dense animal foods with antioxidant-rich plants can provide a broad spectrum of vitamins, minerals, and bioactive compounds that work together to enhance overall health. One of the primary advantages of animal-based foods lies in their superior bioavailability. For instance, heme iron absorbed 2 to 3 times more efficiently than plant-based iron. Retinol, vitamin A, directly usable by the body, unlike beta-carotene from plants, which requires conversion. Plant-based foods, while rich in certain nutrients, often contain anti-nutrients such as phytates and oxalates, which inhibit the absorption of minerals like calcium, zinc, and iron. Modern dietary patterns present a spectrum of options, each with unique implications for health. Vegan diets require careful supplementation and avoidance of ultra-processed alternatives to prevent deficiencies and health risks. Processed plant-based foods should be minimized due to their adverse effects on metabolic and cardiovascular health. Carnivore diet shows promising benefits for specific individuals but requires more research to confirm long-term safety and efficacy. Ultimately, the most health-supportive diets are those that prioritize nutrient-dense whole foods, both animal and plant-based, tailored to individual needs and lifestyles. Aligning modern eating patterns with evolutionary dietary principles can optimize health outcomes in an increasingly complex nutritional landscape. As we've explored throughout this series, the evidence from cellular biology, organ health, human evolution, and modern dietary patterns all points to the significant role of nutrient-dense animal-based foods in supporting optimal health. From our ancestors' hunting practices to the bioavailability of essential nutrients, the story of human nutrition is a fascinating blend of history, science, and practicality. But now, it's your turn to take action. If you found this video informative and engaging, don't forget to hit the like button to let us know you enjoyed this content. Subscribe to the channel so you don't miss any of our future deep dives into health, wellness, and fascinating topics about nutrition and lifestyle. Share this video with friends, family, or anyone who might benefit from learning more about the role of animal-based nutrition in health. We'd also love to hear your thoughts. Use the comments section below to share your experiences, ask questions, or suggest topics you'd like us to explore in future videos. Your feedback is invaluable, and we can't wait to continue this conversation with you. Thank you for watching and supporting our channel. Stay curious, stay healthy, and see you in the next video.